All right, let's get this coffee break started. Thank you everyone for joining. My name is Gene An. I'm a sales engineer over at Long Building Technologies, particularly in the hydronic, steam, and plumbing department. With me today is Trent from Superior. He's going to be giving a presentation on their new dual fuel condensing boiler called the Cheyenne. Trent, you want to take it away?
All right. As Gene said, I'm Trent Thurston with Superior Boiler. I'm in the mechanical engineering side of our Firetube division. And yes, as Gene said, we're specifically talking about our Cheyenne dual fuel condensing boiler. So as we see on the slide here, the sizes on this, it's a larger unit. It's sized from 4 million BTU input up to 12 million BTU input. We do have, through our sales reps, such as Long, we do have all boiler models available in both 2D and 3D drawings. And this table that we have on the right with more details with all the dimensions shown, just a small selection right now. Going quickly over what a condensing boiler is, the biggest reason why you choose it is that condensing boilers are more efficient. They gain this efficiency through the condensation on the cold wall temperatures. Every boiler actually will condense a little bit during cold startup, but to consistently get this high efficiency, you need to have cold water returned to the boiler. For our purposes, the colder the better, but we do understand that there's not very few applications where you can return 80-degree waters back to the boiler. Anything under 130 to 135, you will start to see condensation. At higher temperatures, the only real benefit to this is that these don't require any sort of blend pumps. They are designed to have resist thermal shock. So the reason why we don't always use condensing boilers is that they have some unique design challenges. As I just mentioned, one of them is thermal shock issues with the boilers. This is caused by temperature differentials between the hot furnace and tubes and the relatively cold surfaces and the expansion and contraction at different rates. We deal with this in two ways. The first is that we have all full penetration welds at corner joints and also at the tube to tube sheet connections. Full penetration welds are the best for resisting thermal stresses. They will flex and absorb some of this thermal expansion and contraction. Unique to us is this U-shaped expansion joint in our furnace. The furnace is the spot we are most worried about because that is the hottest part of the boiler, but this U-shaped joint will help absorb some of the thermal expansion and therefore minimize thermal stresses and helping the lifetime of the boiler. You will also see acidic condensate produced whenever there's condensation. With the presence of a high concentration of CO2 and the presence of water vapor, you'll start to form carbonic acid. It's a relatively weak acid. It's not going to burn your skin, but certainly over time, it will cause damage to pipes and other non-corrosion resistant materials in contact with. And it's also illegal to dump down the drain in most jurisdictions. Everything in contact with the condensate is going to be made of 316 stainless steel. We like this due to its high thermal conductivity, and it's relatively easy as far as stainless steel goes to weld and manufacture. In addition, we do supply a condensate neutralizer to neutralize the condensate to a more balanced pH so it can be safely discharged to any standard drain. A couple of benefits of the Cheyenne boiler is that we do have a full-size furnace. Some condensing boilers will have a small furnace that requires a mesh head premix type burner. These burners have high excess air, but do fit inside a small furnace. Our Cheyenne can use those premix burners, but we also can use low excess air burners and also burners capable of burning liquid-based fuels instead of gaseous fuels. This is particularly important when there's a hospital which needs a number 2 oil backup and can't have a gas propane backup. One other thing with this is that when you have a lower excess air, this is the blue curve on the right, you will see more condensation. It's just that with the higher excess air burners, there's relatively less water vapor in the flue gas compared to the total amount of flue gas. So that results in less condensation when you have high excess air. And as we know, our gain here is from this condensate. So with the more condensation, better efficiency. Next couple slides are showing the construction of the boiler. This is just the lower vessel by itself. This is going to show the forklift points here are, generally speaking, how you will move it. We do have lifting lugs on both the upper and lower vessel to help put it in place if you are using an overhead crane. Then next slide, we have the fully assembled 2 vessels without the jacketing. And our standard will be to ship the boiler fully jacketed, fully wired, with burner mounted. However, if there are small spaces that require this to be disassembled, we can ship each pressure vessel separately. At that point, even the largest 12 million size will be able to fit through a standard double door without any modification. Another thing we like about our Cheyenne series is that it is a high mass boiler. What this does is that it is not restricted to a primary secondary system. It does not require a dedicated circulating pump. You can use that, but you can also use variable primary if that helps. While it's not a good idea because you won't get any heat out of the boiler, you can operate this with no flow. Again, it won't work right, but if there is no flow, the temperature limit safeties will trip and shut the burner off before it ever reaches an unsafe condition. It's not ideal, but it does help prevent an unsafe condition if there is no flow and the burner does come on. The other advantage of the high mass is that it will help to reduce boiler cycling. And just due to the fact that temperature will rise slower, so at low loads, it doesn't trip the automatic reset high limit. Another thing we have that is standard in most Scotch Marine fire tubes, but rare in condensing boilers, is that we have access to the furnace with a side port, and also we can open the lid and access the burner. This is particularly important in commissioning because every burner will need to be adjusted when it gets to the job site. Yes, we do test our packages here, but it's tested at 1,700 feet above sea level with the natural gas supply that we have. And at the specific job site, it's potentially up to 5,000 feet above sea level, and every supply of natural gas is a little bit different depending on the utility company. So it is necessary at every installation to tune the boiler burner package to the specific job site conditions. And every burner tech I've met has liked to be able to see the flame at the back, make adjustments if needed, not requiring to pull the entire burner out to be able to access this. Additionally, as we saw a couple slides ago, we have several handholds. This does allow us to access the boiler, to full access and inspect the boiler from just one side. Shown here, we have partnered with several of the leading names in the industry to provide a good product. Our specific offering is just what we manufacture is just the boiler proper, but we do have very good companies to supply the burner and fuel train and safety controls that are required for safe boiler operation. We do supply this full package, and we can supply this with a lead lag system where multiple units are controlled by a single master panel. Moving quickly on to the venting. Venting for condensing boilers is a bit unique just due to the condensing temperatures there. It will condense to flue gas will condense in the stack of any condensing boiler. So it is necessary to have corrosion resistant material. CPVC is acceptable when you are certain that the operation will be relatively cold with under 160 water coming out of the boiler. We would recommend that stainless steel, but it is permitted when the flue gas will be relatively cold, and you know that by your water temperature. PVC is not acceptable under any installation just because it has too low of a maximum allowable temperature. And moving back to the inspection from just one side, this is showing how we would recommend installing multiple units. So we have a pair of units with minimal spacing, and then an aisle between each pair of units and also the wall. So this will allow you to minimize footprint while still being able to fully inspect each boiler. So while this is a relatively new product, we have tested this thoroughly. One thing that we can do is we can fully test our largest size, the 12 million, based indefinitely with simulating the load with this cooling tower that's pictured. We can precisely measure each point. We can control with our pump and piping system. We can control the operating conditions of the boiler. And then we do have an electronic data logger, which is logging flow rates for gas and water, logging temperatures. So we can fully check each point and are not reliant on an operator walking around and just grabbing a specific data point from a clipboard, reading a mechanical gauge. So our testing is kind of broken down into 4 parts. So we've completed all of these at this point, but we first did our proof of design testing, where we made some improvements to our prototype after evaluating performance. We also heavily cycled the boiler, where we had a very low flow rate, fired at maximum fire, which caused it to quickly trip on high limit. Then we increased the water flow rate and also turned the burner fan on to rapidly cool us as fast as possible. We did this took 6 minutes or so did this about 10 times an hour. After doing this for a few weeks, we had our QC department do a dye penetrant test, which would check for cracks, any hidden cracks in the weld, and reveal them. And even after trying to break the boiler, we found no issues with any of our welds, which has given us a lot of confidence in our design. The next phase was UL safety testing. This would check water level controls and also the burner and fuel train to confirm that they worked safely with our boiler. This passed without any issues. Next phase is just the standard DOE test. It has some issues in that it's just 100% firing rate at 80 to 180. But our final phase here was to test it at real life conditions, where we checked part load conditions, checked at 100, 140, which is probably much more common than 80, 180. So yeah, I'm leaving on the final stage our warranty here, which is we are standing by our product. And yeah, I can obviously talk about this much longer, but not to use any more of your time, I'm going to turn it back over to Gene.
And thanks for joining, everyone. Have a great day.